So are there questions from homework?
Did you get that? I have one. 45 and 7.2.
7.2. Oh, all right. So this one here, the 2x squared. All right, so let's try to attack this the regular way, and then I'll show you the shortcut. And then if you don't understand the shortcut, it don't matter worth anything. It's just a shortcut. Here's. How do I go about, well, what do I need to do? Can I, oh, there's threes, yeah. So threes,
No.
2 x's, one is 2 x's. All right, good. Double check. So what do I have to do first? Good. So you want to factor these guys. I don't need LCD. Why do I not need LCD? Multiplication. Right? Can I add x and y?
No.
Can I add x and x squared?
No.
Can I multiply x times x squared?
Yes.
Yes. So multiplication is not as restrictive as addition and subtraction. I do not need LCD for fractions when I'm multiplying or dividing. Only when I'm adding, subtracting. So yeah, Stevie, you're right. You do that. So let's focus on the top first here. You get -6. I need factors of -6 that make -1. And the funny thing is,
2 and 3 and 2.
2 and -3, where that thing came from is already the answer for that. But here's the trick. You can't then just say that the answer is x minus 2 or plus 2x minus 3 or something like that. You have to break up the middle term, right? So it'll be 2x squared. So I would turn these around, make it minus 3x plus 2x minus 3. So I'm just going to focus on the top. And then, of course, you do what? Group. Yeah, all right. And when you do that, you're going to see this. You already see it there, but you don't start killing anything until you're completely done factor. Because you're not allowed to in the first place. So what comes out of here? What comes out of here?
2x. Oh, negative.
Don't overthink it. Nothing comes out of there. So what comes out? What? Never nothing. It's always at least 1. So you get x plus 1, 2x minus 3. All right. I'm not going to do this whole problem. We're going to do the bottom. But that's what I would put up here. And then I could see that the 2x minus 3s would be able to cancel there, right? For example. So real quick, here's the shortcut. Is everybody cool with that? I mean, that's old news. You just take that, put it by itself, work it out, put it back in. Take that, put it by itself, work it out, put it back in. See who dies. The shortcut way to do it is to go, the only way this could actually reduce is if it had this in it. So then I just say, let me see if it has it in. Let me put it down there. What times what is 2x squared?
X.
Yeah, 2x times x is 2x squared. -3 times what is -3?
1.
And isn't that what we got here? And you can check it, -3x plus 2x is -x. You got to make sure that it actually is true. And that's the shortcut. It's a shortcut because this is telling me, this is giving me a clue what might be in there. So then I try that. If you don't like the shortcut at all, that's perfect. I don't care. You don't have to understand it at all. Just do this. It's, more practice factoring. I can't ask for more than that. I like it. So a lot of shortcuts. It doesn't really matter if you understand them or ever want to use it. They're just shortcuts. Do it the long way, and hey, there's nothing wrong with that. Is that cool? You can do the same thing on the bottom, or you can do the bottom this way. Again, if you don't quite get the shortcut and you really want to, come see me. If you're just let it go, that's fine. You have to be able to do this anyway. Yeah.
Can you do problem 100 on 716?
The one about the waiting in line?
Yeah. Wait. I think so.
Problem 100?
That's it. So, quick question about this. The bottom, how we break it down.
For this guy?
Yeah, it's basically just the same way.
I like that. All I had to do was like that. It's the Denny's method of teaching.
What was wrong with
So you sure it's 100?
Yeah.
100? Okay.
Oh, so we do it 100?
So 7.6 100. They give you this as the time spent waiting in line at the post office. I waste all my patience in the classroom, by the way. I think I'm a pretty patient person. You don't want to see me in line at the post office. It's the longest line. I'm like a little kid. I'm like, come on. So customers arrive at random. The average time spent waiting in line is given by this, where X is the number of people coming in per minute. I like it. So you can see a problem already, sort of. I mean, what happens if X is 4? It's undefined. It's like infinite time in line. That is my personal hell. Right?
Jeff, go back to the back.
Oh my God. So part A just says plug some stuff in for X, right? Part A just says plug in X equal to 3, plug it in, figure out what T is. So part A shouldn't be a big deal.
Okay.
Part A is just plug it in, see what happens. Right? Let part A be nice. And notice what they're doing. They're letting X be 3, then they're letting X be 3.9, and then they're letting X be 3.99. What are they doing? Where was the problem spot here? What number can this not handle? 4. So what are they doing? They are getting really close to 4, right?
Yeah.
I don't know. This is the idea of what's called a limit. The limit of this is X goes to 4. Let me let X here really close to 4 and see what's happening. Right? Because I can't let X equal 4. Let me get really close to 4 and see what's happening. And then part B just says, do that. Part B just says, find X when the waiting time is 5 minutes. So part B is just put 5 there. Yeah. It's all about knowing what your variable means and where to put the number they give you, right? T is time in minutes. X is number of people per minute. Okay. Anything else from homework? Homework questions? All right. So a couple little things I want to review, and then I'm going to give you guys a handout to work on. Is that a function?
No.
Yes.
Does 1 go to more than one thing?
No.
No, only goes to 7. Does 2 go to more than one thing? No, it goes to 7. Does 4 go to more than one thing? No, it goes to 1. So this is a function all along. Because what's the definition of a function? For every
Input has to be
input, there can only be one output. I like it. So for every input, there is only one output. So how would I draw this so that it wasn't a function? What would have to happen? So if I had 1, 2, 7, 3, I could go 1 goes to 7, and 1 goes to 3, and then that's the problem. 1 is trying to go to more than one thing. I asked the first person, what size shoe are you wearing in your left foot, and they say 7 and 3. But here, I asked the first 2 people, what size shoe are you wearing, and they both say size 7. Well, they can do that. I don't go to the store and say, oh, somebody already bought size 7. We got size 23 and size 0 left. You know, size 0 shoes. That's barefoot. All right, that's one thing. All right, that captures a few things. The idea of function, what makes it a function. Okay. And then something else I want to make sure you understand. All right, don't say anything out loud. Can you do that?
Yeah. I'm sorry.
All right. Now, how do you do this? So g of x is x squared minus 2. So g of 3 is 3 squared minus 2. All it is substitution. Wherever I see an x, what do they want me to put in there? 3. So wherever I see an x... Do you see what I'm saying? Yes, sir.
How come it's not G times 3?
I like it. All right.
That's what I was
All right,
thinking.
all right. Good. We haven't really... All right. Give me a second. We haven't done... I keep bringing this up because this is a perfect example for this. But how do you say this? How do you say that? No. Don't do it. Square root of 9. This is not square root symbol times 9. This is a 9 that has been put inside of a square root symbol. Is that cool? So this is a 3 that wants to be put into the g function.
So it's a different use of of.
I love it. So it's not percentages of or fractions of. It is a function of something means the function value at that
Use
place.
of in English.
Yes, I like it.
It's just confusing because you learn that and distribute the parentheses.
I know. So this is a symbol. This is a symbol that means yeah. So these parentheses don't mean multiply. They just collect what I'm throwing in there. I like it because later we'll be doing stuff like throwing in that into the function. Not yet. So I want parentheses there so I can collect everything I'm supposed to throw in there. So that's the only reason those parentheses are there. Just say, what do I put into this? Whatever's inside the parentheses. That's what I put in. So I read this as g of 3, the same way I read square root of 9. For the same exact reason, I'm putting a number into a function. So that tells me to put that number into the function, and then I do get 7. So g of 3 is 7. Let me let that sink in. How are we doing there? Is that cool? Do not divide by 3. That doesn't make a damn bit of sense. Right? If I said square root of x equals 9, you wouldn't divide by the square root symbol or something. That doesn't make any damn sense. This means the function evaluated at 3, so another way to say it, is 7. Nothing more to do, because this isn't times, this is one symbol. What if I were going to graph this? What point would it go through that I know? So a point has how many parts to it? 2 parts. So I know that y is 7 when x is 3. So that another benefit of this notation is I can see the point. As I do the work, I don't lose the x value. I can see it. Okay, cool. All right, let's try it out. Let me give you a couple of those. Let's see what happens here.
Will it be declared that f of x is being used and it's not an algebraic situation?
They have to tell me, given this, then do these. And they'll give you several, g of 3, g of 7, whatever. Yeah. They could also do this. Given f of x is x over x plus 1, and g of x is what, Jeff? I don't know, man. X cubed minus 7x. I like it. Find g of 2 f of did you make something up, Jeff? There you go. Just try that real quick. Just keep in mind. Oh, come on, don't say it out loud. keep in mind this is just substitution. That's really all function notation is. Substitution. So real quick, I give you two things, right? So I love it when people ask, where do I put the 2? Well, the problem tells you where to put it. The problem tells you to put it into the G function. That's the next benefit of having this notation. I can have many functions listed. They're not all y equals, y equals, y equals. And I'm like, which one do I plug the damn thing in? Now I can give them all different function names. So I know exactly which one I'm talking about. So how do you do G of 2? Yeah, so wherever you see an x in G, you're going to put a 2 there. Because now you know x is 2. So then you rewrite that as 2 cubed minus 7 times 2.
8 minus 14.
8 minus 14? Negative 6. So what point does G go through that I know?
2.
2 and negative 6.
2 comma negative 6. So it goes through that point, if I were to graph it. So what about this guy?
3 over 3 plus 1.
Good. Wherever you see an x in the f function, replace it with 3. So 3 over 3 plus 1. Sweet. All right, let me see if I can blow your mind a little bit. Yes, Jeff, you've definitely shown us that you can do that. What is G of W?
Don't know.
Sure you do. You totally do.
0.
What did you do when I said G of 2? What did you do with that thing inside? You put it in where we saw an x. So what's G of W? Yes?
W cubed minus 7W.
What does this say to do to x? Cube it, and then multiply it by 7 and subtract, right? And it says, what do I do with x? I put the x there and there. So what do I do with W? The same damn thing.
I didn't know we were so
Really? Come on.
I don't know where it came from.
What?
I didn't know you were so
Where did that G of 2 come from?
I thought you were just
Oh.
throwing it up there.
That was the third one of the same thing.
Oh, yeah.
I was like,
Oh,
what do
I'm
you
sorry.
mean?
It's 1, 2, 3. All dealing with this.
Okay.
Right? My bad, my
That
bad.
makes sense.
I do have to tell you what the function is. I can't just go, what's C of 7? Tell me now.
Nothing.
3? No, alright, sorry. So I am talking about this G function. I've already established that's what G is. So then G of W, just plug a W. Do you guys see that? It's almost too easy to believe, but that's the idea of whatever I put in here. What do I do with it? Put it, holy crap, put it wherever there's an X. That freaked me out. Cool, alright. Where you go? There. So let me give you this handout. Let's see what happens.